Section 4 of Chapter 1 is all about the distributive property. So by the end of this lesson, you should be able to use the distributive property to do two things: to evaluate expressions and then to simplify them. So the distributive property says that if you have a number being multiplied on the outside of a sum or a difference of several other numbers, you can multiply that number in to all of those things. So it says here that if you have A times B plus C, instead of adding B plus C together, you could multiply A and B together, multiply A and C together, and then add them. And the same thing works for subtraction. And this even works for a giant expression. Let's not use A again. If we had B plus C plus D minus E minus F plus G, this would still work as long as you multiply A by all of these things that are on the inside. So let's use the distributive property with the story. A group of 7 adults and 6 kids are going to a baseball game. Let's use the distributive property to write and evaluate an expression for the total ticket cost. So if we come over here and look, a single game for an adult costs $5. A single game for a kid costs $3. But if you have a group of 10 or more, it's going to cost $2. So we definitely have 10 or more people going. So we have $2 per ticket times the amount of people that are going. And we could add these together, but because it says to use the distributive property, we're going to do 2 times 7 and then 2 times 6. So you end up with 14 plus 12 for a total of $26. So I find the distributive property really useful to do mental math with. So when you look at these numbers, 304 times 15, you could set them up like this and do the whole 5 times everything, then 1 times everything, or you could do lattice. Or 304 is very close to 300. So you can think of this number here as 300 plus 4. And then the distributive property says that I can do 300 plus 4 times 15. So what I can do in my head is 300 times 15, and then add 4 times 15. So 300 times 15, my head is actually going to do 3 times 15, which is 45, and then add 2 zeros on it. And 4 plus 15 is 60. So this comes up to be 4,560. Same kind of thing with this next one. 44 times 2.5. Now remember, 2.5 really means 2 plus 1/2. So the distributive property says I can do 44 times 2 plus 44 times 1/2. And 44 times 2 is 88, and 44 cut in half is 22. So this ends up being 100. Oh, 110. I'm going to save these two for you guys. So now let's get into some algebra with it. So a big reason we use the distributive property is because we can't simplify what's inside of the parentheses that we have, like this next one. So GEMDIS would tell us, combine what's in here and then multiply. But because we can't combine 8 and 4n, the only thing we have left to do is distribute. So this turns into 8 times 2 plus 4n times 2. So you end up with 16 plus 8n. Now this one's a little trickier because there's 3 things inside of the parentheses and there's a negative on the outside. So be careful when you distribute it. You have negative 6 times r plus negative 6 times 3g plus negative 6 times negative t. So when we simplify this, we get negative 6r minus 18g plus 6t. And that's it. And just like before, I'm going to save these two for you. So why did we leave those things like we did in the last problem? Remember that like terms contain the same variables with corresponding variables having the same power. Remember that terms are separated by addition or subtraction, so that means we have 3 terms here. Like terms have the same letter and the same power. So this term and this term are alike because they both have an a squared. And now even though this has an a and this also has an a, because this isn't to the second power, they are not like terms. And we can combine like terms using the distributive property. So chances are if I would have given you this problem before, most people would have told me that it's 12k. But the reason you can do that is because you can undistribute this k that they both have in common and rewrite it like this. And then we can do 4 plus 8 to give us 12, multiply it by k, and that's how we end up with 12k. When I ask you to get something in simplest form, it means that it contains no like terms and no parentheses. If you have like terms or parentheses, you're not done with the problem yet. So simplify each expression. If not possible, write simplified. So the first one there, 6n minus 4n. Now because both of these have an n, we can use the distributive property and undistribute that n that they both have, do 6 minus 4 to give us 2n. And we're done. Now this next one, we have a b squared, plain old b, and a number without any b's. These are not like terms, which means this is totally simplified. We can't do anything else with it. Just like before, I'm going to leave those two for you. So let's say I asked you to write an algebraic expression, simplify the expression, and then tell me what properties you use. So this is kind of bringing together everything that we've done so far in Chapter 1. So the expression is 5 times the difference of q squared and r plus 8 times the sum of 3q and 2r. So 5 times the difference of q squared and r. 5 times. The difference of these things means I'm going to subtract. So I have q squared and r. And then plus, oops, go back. 8 times the sum of 3q and 2r. So 8 times the sum, which means I'm going to add 3q and 2r. So using the distributive property, I can simplify. So I'm going to distribute this 5, and then distribute the 8. Then I got to combine my like terms. So q squared doesn't have anybody to combine with, so he's going to stay. R, we have negative 5 plus 16, so we'll end up with 11 r's. And then 24, q doesn't have anything, so he's just going to stay by himself as well. So now the properties that we used, right here it was the distributive property. And then right here we combined like terms, which is technically using the distributive property again. And this slide isn't supposed to be here because it was from the other notes. So we're done. Can you use the distributive property to evaluate expressions? And can you use it to simplify expressions? If you think you can, go back and do the problems that I left for you. You got 2 here, 2 here, and 2 there. Make sure you write down any questions you have and we can go over them in class together. Enjoy your night.